Hi, welcome to class. My name is Don LaFont, Professor Don, and this week in our A-plus hardware class, we're covering Module 7 storage devices. I think this information is interesting. It's definitely something you'll use because we're always adding or replacing a hard drive to add a little more space, or perhaps we had a hard drive go bad. So this chapter will help you not only as a technician, but also maybe in your life. So let's go ahead and let me share my screen. If you are here with me live, I want you to hold your questions, if you have any, until the end of the I'll allow you time to ask your questions. If you're watching this as a recording inside of our Canvas classroom, then please ask in the help discussion forums. And if you're watching this online, first of all, welcome to my channel. I appreciate you coming. Hopefully this video will be useful or helpful for you, again, either in your own life with replacing or adding a storage device to your computer, or in your earning your A-plus certification. I'm going to, let's see, I shared my screen. Please ask questions down below if you have any, and I will be out in the comments down below, and I'll be happy to answer those questions. But please feel free to answer each other questions. That will be fantastic. I love that community that's really awesome. One sec, one more. And storage devices. So in this presentation, we'll cover in-person and phone skills. That's our soft skill topic. We'll talk about storage devices and drive overview. We'll talk about storage device configuration overview. We'll talk about partitioning a drive, high-level formatting, Windows disk management, and what to do when you have slow performance. Qualities of a good technician, soft skills, and in this case, we're talking about communication. Now, I actually have quite a bit of skill, I think, when it comes to communication online and in person as a teacher. But you need to, when you're interacting with people in person, it's a little different. You can use gestures, you can use your hands to emphasize points. You can draw a graphic to illustrate a concept. You can perform some steps needed for troubleshooting faster because you can do them yourself instead of trying to walk somebody through them. And you can show empathy, which is really important. It's more easily done with body language, actions, and voice in person than it is, say, over the telephone. Now, when you're on the phone, I worked for a company taking tech support phone calls for 3 years. And in that 3 years, I took 30,000 technical support phone calls. So I have a little bit of skill when it comes to online, or should I say phone communications. When dealing with somebody on the phone, you got to use the following components. Well, you have to identify yourself clearly and pleasantly. I actually learned doing this that you have to state your name, your first name, pause, and then state your last name. It's a really weird dynamic because we normally say, hey, my name's Don LaFont, Professor Don LaFont. But online, you can't see and hear the division. So I got into a habit of saying, hi, I'm Don LaFont. And that pause made it made a difference because people could say, hi, Don, how are you? Think about all the times somebody told you their name and they jumped into troubleshooting and you're still trying to figure out what their name is. Avoid using a condescending tone. What did you do? Not a good idea. Be patient and speak slowly when giving directions. Use active listening skills. Avoid doing other tasks when you're on a call with somebody. When you're typing, they can probably hear those keys being tapped, and that's distracting if they're trying to explain something and they hear you typing. Often they think you're not listening to them, and you might not be listening to them. Avoid using acronyms and technical jargon. Remember, the first time you say any acronym, should actually tell us what that acronym stands for. So, for example, in this presentation, I have a slide that I created and added to the presentation for RAID. Now, when we get there, I actually typed out what RAID stands for, even though nobody ever uses RAID, you know, what the actual name is. We all call it RAID, RAID 0, RAID 1, RAID 5. We always refer to it that way. But in reality, it stands for something else. If you say RAID, non-technical people are going to be thinking you have a can of RAID and you got a bug problem or something, or you're going to raid, you know, air raids in Germany or elsewhere during one of the wars, right? So RAID isn't obvious unless you're a technician when you talk about setting up a RAID. So that's just an example of using the actual term. Tell us what it is, then tell us the acronym, and then go about explaining the acronym. Avoid being accusatory or threatening. Have you been turning off your computer without using using the on-off switch on the back? No, don't do that. You know, you may suggest always turning off properly using the start button and ejecting or your USB drive. Have you been yanking your USB drive? No, don't. Just remember in the future to properly eject your USB drive by using the arrow on the bottom right-hand corner and finding the little drive icon and ejecting your USB drive. Those are the kind of ways you want to tell somebody that will help, and explain why. Talk about how just yanking it out might short the drive if it is in the process of writing and reading, and you may never be able to access that drive again. If the computer is a customer is irate, try to calm the customer down and help him or her. However, if the customer continues to be belligerent, turn the call over to your supervisor. I was taught when I had that job back at I don't want to really tell you the name of the company. I can tell you. I worked for America Online back in the day with dial-up modems. Let's just say I had a few irate customers that kept getting dropped offline, and it was a slow connection as well. So the combination was never fun. And one of the things we were taught was to always let the customer vent. Let them get it all out of their system. And at the end, no matter what they say something to the effect of, I can help you with that. And then repeat what you think they just said. So I understand you keep dropping offline and occasionally you can't even get online. Is that correct? So, and then what they will do is they'll say, yes, that's correct. And they might even repeat themselves again to clarify, but you need to let them know that you understand the problem, and you need to let them finish explaining the problem. If you interrupt what they're saying, then they might start all over again. And if they're irate, that could really escalate. If it's beyond your skill level, don't waste the customer's time. Go ahead and escalate it. Hey, this is a level 2 issue, or let me talk to, can I put you on hold for a moment? I need to talk to somebody about this. And I'll get right back to it. I need to research the problem. Let me get right back to you, okay? And then check back into them. Don't leave them on hold for extended periods. Even if you're working hard on your end, a 20-minute wait is completely unacceptable in today's world. With short attention spans, they're going to think you forgot them. So even if you're still working on the problem, pop back in. Hey, I'm still working on it. May I have 3 more minutes? Then go do it for 3 minutes and pop back in. It's like, hey, I'm making some headway. May I have 3 more minutes until you finally solve the solution? Make sure you speak clearly and loud enough to be heard easily. Avoid having a headset microphone pulled away so it is hard to hear you. If you are asked to repeat something, speak louder or adjust the microphone or headset. And then, of course, avoid eating, drinking, or chewing gum when on the phone. One more thing that they don't mention in this chapter, but I want you to do it. I want you to think about it. When you are on the phone, smile. I know it sounds weird, but people can hear a smile. I don't know why. I don't have a psychology major. I just know that when you're smiling, when they hear it in your voice, and you may not have a joking around personality, but if you do, it's okay. Don't make fun of them, but you can joke, and don't make fun of your company, obviously, right? But if you have an opportunity to make humor of something that we can all make fun of, like the weather, for example, then it's okay to throw something in there. All right, very good. Storage devices and drives. Let's talk about the overview. So storage devices hold data, uh, and all of the devices you see in front of you are all what we call. Um, Hang on a second. Okay, great. So all of the devices you see in front of you are all non-volatile storage. And what that means is when you turn off your computer and then turn it back on again, the data is still on the devices, whether they're CDs, which is pretty obvious, or a hard drive, or an SSD, or a thumb drive, or a myriad of other storage devices. It's non-volatile storage. That's why we have it. Remember, we talked about RAM earlier in the course, and RAM is volatile. We turn off the computer, and then you turn it back on again, and it clears the RAM. And then when your computer comes back on, it takes the data, which is stored on the devices you see in front of you, mainly a hard drive, SSD, M2 drive, or something like that. And although it could be a flash drive in today's world, and it loads that operating system back into RAM. The RAM is volatile. Turn off the computer, goes away. The hard drive is non-volatile, and that's really important because you don't want your installed programs to go away. Storage devices hold data, photos, PDFs, movies, word processing documents, and spreadsheets, and then the actual OS itself is stored on a storage device. Data is stored on optical media, flash drives, magnetic media such as hard drives. Data may also be stored in the cloud, which means it's stored on somebody else's network and available through the internet. Drives are popular devices for storing data. They can be mounted inside the computer case or attached externally. You can store more data than on a hard drive than on a flash drive, and you can move that data faster than tape drives. So if you have a hard drive as a backup, for example, then you can access the files much quicker on a hard drive than you could if you had all of your databases, for example, on a tape backup. Today's hard drive capabilities extend into the terabytes. I remember, and I like to tell the story, but I remember back in the early 90s, I bought a 200 megabyte hard drive. And I remember saying, and it was $200. And I remember saying to my wife at the time, I said, "It's okay, honey. I will never need a larger hard drive than this." That was back in the day of floppy disks, and what were those, 1.44 megabytes, and so 200 megabytes for a hard drive running Windows 3.11 was ridiculously big. In today's world, I have a 14 terabyte hard drive that cost me just a little over $200. And you can get hard drives much larger than 14 terabytes. Single hard drives, I just don't want to pay $300 or $400, but you can get single hard drives that are much larger. Matter of fact, let me see what the largest hard drive is in the summer of 2022. Hold on just a second. And one of my preferred shopping websites, newegg.com. Amazon's also fantastic, and I bought things on Best Buy as well, so I don't want to single out any online retailer, but Newegg is fast and easy. And I put 4 terabytes or higher for the size, And you can see you can get, let me go ahead and go low to high. 4 terabyte drive is $40. That's a good company. I'm not picking out on Seagate, although it doesn't have many stars, but let's just go with drive. And let me go to the other end, highest price, and a 20 terabyte hard drive, 15 terabyte, but this is a network hard drive. So let's just take the checkout here and just go with 20 terabyte lowest price, and you'll see get the lowest here, $384 for a 20 terabyte hard drive. $384 if you had a 10, you can get two 10 terabyte drives, so less than, it would be $198 each. So here, $300, you can get two 10 drives. So when you're deciding on what hard drives to purchase for your computer, if we're talking about storage for music, movies, pictures, etc., file programs, etc., then you can expect your drives you have to determine what size hard drive you want, and then how much space you have. So if you have room for two hard drives, two 10 terabyte hard drives would take up less space than one 20 terabyte hard drive. I mean, more space, but it would be significantly cheaper. So that just makes sense. I hope that single larger drives would be more expensive than multiple smaller drives. And you have to make a decision there. They also take up more power. Having multiple smaller drives takes up more power. So you have to weigh that as well. Not a lot, but enough that you have to be aware of it. So that's the hard drives. Now, I didn't pull up SSDs. SSDs we'll get into we'll get into here in a moment. SSDs don't have moving parts, and we'll talk about it in a little bit. Mechanical drives actually have, and I have a picture coming up in a little bit, the mechanical has a platter that spins, whereas a solid state drive uses flash memory, much like your USB thumb drive uses flash memory. Nothing's moving in that stick that you put in your pocket, right? Even when you plug it into the computer. A hybrid has a little bit of both. It is a hard drive with platters that uses SSD flash memory as temporary storage to make it a hybrid between the two. Types of SSDs. I remember when M2 drives came out. M2 drives are these smaller drives, right? And that's the same thing as an SSD. This is not to scale. An SSD is actually much larger than an M2 drive. This is really showing you an SSD in a wrong form factor. It's a better picture of that is the previous picture that showed the size of an SSD. This is a standard size SSD. Again, it's flash memory, so it's more like your USB drive except larger. So you can it's why do we have mechanical drives when we have flash drives that are faster? Well, mechanical drives are cheaper, and you have terabyte hard drives, and I can actually show you that as well. So let me hit pause here again for a moment. All right, and so here we have the website, and I have SSDs pulled up. And let's go back to the capacity again to 2 terabytes and up, and apply that, and you'll see the price is a 2 terabyte SSD and M2 drive, and it's $219. That's for 2 terabytes. We saw earlier the hard drive for $200, we could have more than 10 terabytes of hard drive of a platter spinning, that type of mechanical drive. Here is the more the older 2.5-inch internal SSD for that 2 terabyte. Actually, this is only 560 megabytes for almost $200. So I can't narrow. Oh, I can over here. So let's go to that same. We were looking at 4 terabyte drives, right? So let's go to a 4 terabyte drive, and then and a 4 terabyte SSD, 300 the price of the hard drive. And if you want it's a little bit faster, at $578 for this drive right here for two. This is 4 terabyte. I'm just interested in what a 15 terabyte SSD costs. I can't even imagine what that's going to be. $3,000, $3,000 for 15 terabyte SSD. That's pretty impressive. I'm not buying one of those anytime soon. But heck, if you're running a server and you have only space for one drive and you want it to be the fastest it can be, and here's 15 terabytes for $3,000. Now, the exciting part about that is if this exists at 15 terabytes today for $3,000, wait 10 years and this 15 terabyte drive will be $300. I know that experience because I bought hard drives all the way through all of the pricing points. That first 1 terabyte drive, I bought it. The 2 terabyte, I had it. The 4 terabyte, the 8 terabyte, the 10 terabyte. I don't know if I had a 10 terabyte. I know I ordered a 12 terabyte, and I know they sent me a 14 terabyte. I didn't complain about that. But the so I have a 14 terabyte hard drive. That's my biggest drive, but it is a mechanical drive for storing space, storing movies and whatnot. Way more than you actually need, probably. I haven't even made a dent in it. All right, so that's enough about the pricing point. And let's keep going with the presentation. NVMe, non-volatile memory express. I talked about non-volatile as well already. M2, it's got faster performance installed in a PCIe slot or an M2 connector connected to a PCIe adapter. And so it is faster than having a SATA connection. We're going to talk about SATA next. So M2 drives are faster than the SSD that I was just talking about. This guy right here, this is the same size. They do come in different form factors, but this is what they look like. How do they connect? Well, hard drive interfaces need a set of rules to operate. Okay, the rules specify the number of heads on the drive, what commands the drives respond to, the cables used within the drive, the number of devices supported, the number of data bits transferred at a time, and so on. Hard drive interfaces that exist. Let me give you an example of that. So I have an external RAID cabinet, and when I bought this RAID cabinet, it said the maximum hard drive space that could go in it is 4 terabytes. For each one of it. It's four terabyte hard drives, and I run it in RAID 5, so I get redundancy and 12 terabytes of backup space for everything I do, and I'm happy with that. But they did come out with an updated driver that allowed me to put an 8 terabyte drive in that cabinet. Now, of course, I'd have to take out the 4 terabyte drives and replace it with 4 8 terabyte drives, which I have never done yet, because I don't necessarily need 24 terabytes of backup space. Now, someday I may need that much space, and by then, hopefully, 8 terabyte drives are under $100, and I'll be able to replace it for $200-300 to replace my existing RAID cabinet, because I have to remove that RAID cabinet unless I buy a whole additional RAID cabinet. Anyway, so the rules change over time based on drivers that exist for the drive sizes, and we'll talk about actually, we'll talk in this presentation, we'll talk about the different formatting features for hard drives, because different size hard drives required different size expanded formatting. Now, another thing they needed was a different interface. This interface cable right here, this is the old ATA cable. And if you open up an old computer, one that's 15 years old or so, maybe a little bit older, you'll find a whole bunch of these run in there, and they're actually gray in color. That, if you see that in your computer, it's time to upgrade the computer, because really we're talking about a very old system, which probably has USB 1 on it, black USB connectors are USB 1, and this is the same time frame that these say. Actually, this goes all the way back to the 80s when computers came out. This is what they look like. But for at least 15 years, we've been using serial ATA cables. Serial ATA cables are faster and obviously smaller, much more better, much better for cable runs in your computer, because these are very inflexible, not very flexible at all. These are very flexible, and you can run them and group them and make your computer case look pretty. So let's see, did I miss anything here? Parallel PATA, parallel ATA cables are, that's what that is right there. ATA even goes way back. ATA is a format for AT attachment, and then we have parallel and we have serial. This is SATA and this is PATA, and then they actually renamed this to PATA. It wasn't PATA at first. Anyways, we also have small computer systems interface SCSI, serial attached SCSI interface cables, not shown here as another type of cable you found in network servers. Now let's talk about the hard drive itself. So remember, I told you, when you get a new hard drive and you put it into your computer, if you're just adding storage space, then you just need to partition it to a high level format, which is a step we actually talk about in this presentation. The hard drive looks like this when we're talking about a movable hard drive, the less expensive option I was talking about earlier. And it has platters, and these platters actually spin, and an arm called an actuator actually spins along the top of it. I have a video of that. Hang on just a second. Let me show you what that looks like. All right, so here is a video that I found online. You can easily, there's lots of them out there. It seems like every technician with an old hard drive wants to show what it looks like, but I do appreciate this web page for putting this video up here, and I'll expand it. And you can picture this platter has multiple layers, and that actuator arm that's going up and back and forth is actually accessing files, reading and writing to the hard drive, and it does it quickly. Now, you would never want to actually open up a hard drive that you care about, because the human hair is too wide to fit between the actuator arm and the disk itself. I forget the actual millimeter distance, but a human hair is too wide to fit in the platter itself. So that's what 1,000 RPMs or 7,200 RPMs. I actually had a hard drive at one point that got popular at 10,000 RPMs, but man, that was so loud that it was expensive and loud, and it didn't show an improvement. Just spinning this platter at 10,000 just made way too much noise, and when it died, I didn't miss it and never replaced it. You don't see 10,000 RPMs anymore, at least not. I haven't seen one in a while. It's all 7,200 RPMs. Or the power savers are, I think, 5,400 RPMs. But anyways, it's how fast this guy's spinning. Anyways, that is a hard drive spinning. And let me remove that. back to our PowerPoint. That's what that looks like. This is a picture of that original IDE standard, which was known as ATA, and then they renamed it as PATA, PATA, and it had a connector, a gray cable that had a slave and a master, and you actually had to use dip switches on hard drives to identify which was the master and which was the slave, and you had to connect it to the proper cable outlet, cable connection on the drive. And of course, your motherboard didn't have more than one, or I think it always had two on it, because you needed something for the hard drives, and then you needed something for floppies, 3.5, or back in the 5.25 inch days. But the so these cables were very limited. Today's computers use SATA, point-to-point interface connectors, which means each device connects to the host through a dedicated link, and each device has the entire interface bandwidth. Most motherboards today come with 6, 8, 10, or even more SATA connections. I have a video to show you that interface. Let me prompt that video. Hold on a second. Good boy. Okay, here's the video.
Hi, Cheryl Schmidt here with the introduction to PATA and SATA. So PATA is a term that actually did not come about until SATA came out. So PATA is the older technology, and it stands for parallel ATA or parallel AT attachment. And PATA was a technology that was created in order to attach internal only storage devices such as hard drives, tape drives, optical drives. So today, you might find a computer, lots of computers that still have PATA drives installed, and so you might have to replace it. You might have to, they might want to keep it and put it over in a new machine. So you still have to be aware of PATA and SATA devices and how to configure both of them. Also, your hands-on test number 3 is PATA and SATA, so you need to know how to configure both of them. And it's 50-50 chance as to which one you get. So PATA, the parallel technology, the ones and zeros went down the cable all at the same time. So you would have either 16 or 32 bits, 32 ones or zeros, marching down that cable to go to the other end, all together, sort of like a marching band. And with parallel technologies, keeping those ones and zeros together, getting them to arrive at the other end at the same time was challenging. And so one of the things that happened with parallel technology is you couldn't have a very long cable. 18 inches max is what the industry standard. And even though you could buy a longer one, and some of us have had to because the cases we bought, 18 inches is as long as you're supposed to have one. So one of the things about parallel technology is that the ones and zeros from one wire could interfere with the ones and zeros from the adjacent wire. And so that's called crosstalk. And so it's an older technology. You could only get max so many megabits per second on transfer rates. And so it was a technology that's going away and soon to be gone within your lifetime. So it was replaced with SATA, serial ATA, so a serial AT attachment. And it's a newer technology, and it's a serial technology in that the ones and zeros, one wire carries the data, which is lanes of ones and zeros, one behind another. And so it's like a choo-choo train or a stream of ants. Faster speeds can be achieved with this, and it's used for both internal and external devices. I want you to notice this picture right here. This picture I took is 2 drives, and just physically looking at them. The one on the left is a SATA drive. The one on the right is a PATA drive. And physically, their connectors are different. We're going to talk about that as we go through these series, but just looking at them, they're physically the same size or form factor, but they got different connectors. They have different power requirements. They act differently, but just glancing at them, if you just saw them laying out somewhere, you're not going to be able to tell the difference between SATA and PATA just based on size. So that's not a good one. So let's take a look at a motherboard of what these connectors look like. Here, we'll start with these blue and black connectors right here. This is PATA connectors. There's 2 of them. Each PATA connector, it's a 40-pin connector. Each connector can have a cable that connects to two devices. So on a motherboard such as this that has two PATA connectors, you could have a maximum of 4 devices. 2 devices that connect to this cable, or the cable that would connect to that connector, and 2 devices that would connect to the black connector. Now, SATA connectors here on the top, there's 4 of them, and those only handle 1 device. So 1 connector means 1 device max. So this motherboard could support a max of 4 SATA devices unless you installed a card that included more SATA ports or a card that included more PATA ports in one of these expansion slots here. So let's go on and take a look at PATA ports. PATA are the ones we're going to start with. And so here is a close-up of the 2 connectors. So you can see them. They're 40 pins. They are normally, see right down here at the bottom, they're normally near the power connector. And if there's a floppy connector, which not many of them's going to have that anymore, and then that'll be on there too. All right, let's take a look at what documentation would look like. If you were looking at the same documentation for the motherboard we just saw, here are the PATA ports up here at the top, even though I don't have it circled, those are the 4 SATA ports. But I wanted to show you a close-up of the documentation. This is going to be relevant in a later presentation. So notice how the primary, this is labeled PRI IDE, that's primary PATA connector, and it's closest to the edge of the motherboard. And then here on the right is the secondary SEC_IDE. That's how the manufacturer labeled it. They do not have to label it. It does not have to be labeled on the motherboard. It usually is, but they don't have to. There's no rule that says they have to. So last thing I want to look at is cables. So here on the top are PATA cables, and the very top cable up here, the one labeled older PATA, that cable right there was a 40 conductor cable, and that cannot be used, even though people will sell it to you on the internet today or through a store. That cannot be used with today's PATA drives. Instead, you need an 80 conductor cable, which is these 2 right here, the one in the middle that's black and the one that's gray. Notice how each of these cables that I've got shown here have 3 connectors. 1 connector goes to the motherboard, and then 2 connectors are to support 1 or 2 devices. If you have 1 device, you'll put it out here. If you have 2 devices, you'll put it, these 2 connectors at the end. And we'll go over that during the configuration series. So for today, what's important is this, to make sure you get an 80 conductor. And the reason it's 80 conductor, this 40 conductor one, what they did to change it was they added a ground wire to each of those to prevent crosstalk for the higher speeds. And this one here, it shows you the connectors are very, very close together for the 2 devices. That actually would be hard in a case to manipulate. This is actually the better cable right here that has some space for you. Here on the bottom are SATA cables. You can see a SATA cable comes in different lengths. The red one is, about 8 inches long. And it doesn't matter which end goes to the motherboard, which end goes to the device that you would connect to it. One thing of note is right here on this blue one, this is about 18 inches long, I'd say, if you extended it out. But right here, this 90-degree angle right there, that connector, you can buy SATA cables that have a 90-degree connector, and it makes it easier for some case designs for when you're attaching it to your optical drives, your hard drives. It's just the way you route your cables and stuff. It's just easier if you had one and not have to, sometimes you don't have a space to bend it, like for this end down here. So, but which end connects to where it doesn't matter. So that's your introduction to PATA and SATA. More coming.
That is the author of our textbook. Get that out of the way. Back to let's keep going. Actually, she goes right into the configuration. Let me go a couple slides and we'll see. Again, that's what it looks like on the motherboard for a PATA compared to what it looks like for SATA. And then configuration. Overall steps for installing a storage device are as follows. First, use anti-static handling procedures. Make sure you're not damaging the equipment through electric static. or generated static from your movement. Remove the computer power cord, physically mount and secure the device, and attach the cables. Configure BIOS if necessary. In today's computers, they automatically identify the additional hard drive, but you might have to reorder the hard drive. If you're adding a new C drive that's going to be a new boot drive, then you're going to have to configure the BIOS to identify that new hard drive. Reconnect the power cord to the computer, power on the computer, and if it's a hard drive, prepare the drive for data as described later in the chapter when we talk about partitioning. Let me go ahead and close this, and let's talk about, let me give you configuration. So here, about configuration.
Here to go over some PATA SATA configuration. Well, maybe here we go. All right, PATA configuration. PATA, as you may remember, is parallel in the older type of ATA. And there are two ways in which you can configure two devices that are on the same cable. So one way is one of the device can be configured as master, and then the other device is configured or jumpered as slave, as we're going to see in a minute. The other way that you could do is both devices on the cable are jumpered or configured as cable select. And it's actually where they're at on the cable that determines whether they're master or whether they're slave. But the jumper settings is what we're going to work on first on these two different methods. So first method, master slave, first thing you should know is you can't mix and match. If you go with master slave, then one device is master. And if you only have one device, you always want to put it right here at the end of the cable. So this is a motherboard connector. Here's a connector. And we looked at those cables in the prior presentation. So, and we'll see another one tonight, in this presentation. But the master always goes at the end. And if you add a second device, you configure it as slave. So master and slave, no cable select in this picture. And the way you do this is through some jumpers. And so here's some jumpers of what they look like. This is a black jumper over here and a white jumper on this one. And how the jumpers, whether they go vertical or whether they go left to right and all that, that's up to the manufacturer as to how they do it. So a jumper, small piece of plastic, goes over 2 pins, and it is how you set a particular setting, whether you set it to master, slave, or cable select. So how a manufacturer actually labels these devices and provides that labeling on their particular device depends on the manufacturer. And some manufacturers over the years have none. Now that's actually crazy in today's world, but you know, PATA's going away anyway, but they got pretty good there at the end to label everything, but not always. So cheap models that come from gosh knows where. But here on this is actually an optical drive. And I always found optical drives throughout the years have always been the best to be the easiestly read. And this is an optical drive. So notice how the characters are on top of each other. So CS, the C on the top, the S on the bottom, that's for cable select. SL, that would be for slave. MA, that would be for master. So that's just an example labeling. Here's a couple more. These are both hard drives, PATA hard drives. And so here on the left, you see CS, slave, the word slave, and master. And you actually see the jumper sticking out. If you look really, really close, you can actually see where they actually engraved it sort of in the plastic on the connector on the end of the hard drive. On the right, this is documentation that they provide stenciled on top of a hard drive. And so, you know, manufacturers did this as well. So you can see they're showing a group of 3 pins, and then it's broken out expanded view that if you have no jumpers whatsoever, that would configure this hard drive as a slave. If you put a jumper over the last 2 pins 5 and 6, then you would be configuring this device as a master or just a master that doesn't have a slave, just what they call a single device. Or you could put a jumper over the pins in the middle and you get cable select. So here shows you a picture of everything all cabled together. You got a motherboard, you got a PATA port and a PATA cable. This connector on the end, this blue plastic right here is to help you pull the parallel cable up. I will tell you, I do not like those. I tend to rather grab the ends over here on the side of the connector and wiggles gently, just micro millimeters up at a time to wiggle it out instead of pulling it. Usually you're going to bend pins if you use this plastic piece. Anyway, PATA cable. This gray connector here in the middle, that would be where you would jumper a device and connect it as slave. And let's just pretend that we already have a hard drive and we open up the computer, we take that hard drive out, we look at its documentation, and you can see this is the one that has the breakout that we just saw. But anyway, we're going to say that this hard drive is configured and jumpered as master because we take it out of the machine, we look at it, we have an optical drive that's gone bad, we've got a new one, we need to hook it up to this PATA cable. So what you do is you take a look at the old one and then of what's already there, and then you take a look at the device you're adding. So here's an optical drive markings, and you can see right here, SL is for slave, and because the hard drive's already set as master, then we want to set this optical drive to slave. So let's talk about cable select. Now, cable select, you set through jumpers the same way, but the difference about cable select, it's where you connect the device that makes it, whether it's master or slave, but you have to jumper both devices to cable select for this to work. You can't go doing one device to cable select and jumper another one to master. You can't be mixing and matching. Your jumpers have to both be to cable select. So here's an example of a PATA cable. Now, I'm going to tell you that there is no rule that a manufacturer of a PATA cable had to color code these, but they tended to do so. The blue connector is what goes to the motherboard. The gray connector is what goes to the slave device. And then this black connector on the end is what goes to master device. Now, I'll tell you, if you just have one device that's going in, you'd hook up this blue connector to the motherboard. You would hook the device to the very end of the cable. It's an impedance thing. It's for the proper amount of electricity to flow through that cable. You're gonna have to trust your old teacher on that one. So anyway, it's showing you here, motherboard connector, it's labeled the same. This connector in the middle, it's, if you, the gray connector, if you connect a device here, that device will act as the slave, but it's actually jumpered as cable select. And by the way, you really want your fastest devices, which are usually hard drives. Hard drives are always faster than optical drives. You always want to make them master. The faster device, the more current device. So here's the same kind of picture. We got a PATA drive, same cable that we had before, but this time our hard drive is jumpered as cable select, and we've got an open connector here. We want to add an optical drive. Here's the optical drive marking. So look how the jumper is different. See right here, cable select down here. That would be how we cable the optical drive. And so that's gotchas. So the gotchas, be careful. Always check that the device that is already on the cable, you got to take it out of the machine. And I will tell you, years of being support and teaching, that's what everybody just wants to second guess, and then it doesn't work. So you always want to pull that device out and check whether it's master or cable select, and never assume that even if you have two devices from the same manufacturer, don't assume that the settings are the same or that the jumpers pins are the exact same settings. They're not. If the first device is master, configure the device for slave. If the first device is cable select, set the second device to cable select. So you have to use that master slave setting, jumper settings, or cable select on both of them, jumper settings. All right, so SATA. Oh, we're almost done here. SATA. You're going to love SATA. One motherboard port, one SATA device. None of this master slave garbage, none of this cable select. You plug the cable into motherboard, you hook it up to your SATA device, and you're done. The one device per motherboard port. Don't forget power. Most probably common thing on SATA. I don't know why. I don't know if it's because it's a black connector. I don't know. But you may need to do your power supply. You may only have Molex connectors coming out of your power supply. That's all you've got left because you have so many SATA devices. So you may have to buy a Molex to SATA converter adapter. It's very cheap, $5 part. SATA comes in 3 different types: SATA 1, SATA 2, SATA 3, bigger number, faster speeds. So anyway, hope you enjoyed. Good luck.
All right, so I just want to add that now SATA 6 is the standard, not SATA 3, but that video's got a couple years, and I remember you're studying for an older exam, so be cautious where you see SATA 3. It was the fastest speed when she made that video. SATA 6 is now the fastest speed. You've got to be aware which one the exam would want you to have. As she said, those are the steps to add a drive. Remember, whether it's SATA or PATA, you have to configure it, SATA being the much easier drive. Now, once you have a hard drive in your computer physically connected, now you have to partition the hard drive. Partition the hard drive, you still have to do it, even if you have one large partition, which is common. You still have to partition the hard drive to that one large partition. Then you can format it with the formatting that we'll see on the next slide. Partitioning a drive divides the drive so that the computer system sees the main hard drive as more than one drive. There's many reasons to do that, including different operating systems, or possibly you just want one for your dedicated for your for your C drive as your C drive. For your operating system, and then maybe a D drive for data or movies and videos and music and stuff. Organize a hard drive into separate multiple operating systems, as I mentioned. Provide data security by placing data in different partitions to allow ease of backup as well as protection. Use a hard drive. It also allows using the hard drive to its fullest capacity based on the formatting type. We'll talk about that in a couple minutes as well. Partitioning, wait just one moment, please. And I have a video on partitions that I want to show you. And this is from one of my favorite online educators. This is a Tech Quickie. And here is, what are partitions?
So back in the time of the dinosaurs, it was pretty much a necessity to partition or divide up your drives, especially if you were running a higher capacity drive on an old operating system such as Windows 95. And believe me, having to deal with like 12 partitions because of file system limitations was kind of a drag. Nowadays, though, with everyone on a Windows-based PC anyway using NTFS, partitioning is no longer necessary, but it can be a valuable tool. So what exactly then is partitioning, and why is it still relevant when we can just dump everything onto one giant 8 terabyte drive and be done with it? Well, partitioning means splitting one physical hard drive or SSD into several different logical drives or volumes that your operating system will treat as if they were completely separate physical drives. Each volume on a partitioned disk has its own drive letter, like C or D or Z, and folder structure, and can also be formatted, even with different file systems, without affecting your other partitions at all. So if you're just rocking one drive in your system, partitioning allows you some pretty cool functionality. You could set up a hidden partition with no drive letter assigned, so non-tech savvy roommates won't be able to find a particular virtual drive. Many PC manufacturers include recovery partitions that are hidden away and have all of your operating system and drivers and pre-installed applications there ready for you to say, hey, I'm ready to restore my PC. Or if you wanted to dual boot your system, very useful if you wanted to try out Linux or run a previous version of Windows for improved compatibility without installing a whole new physical disk or getting rid of your more modern operating system. Multiple partitions can also help keep your data safe if something happens to your OS installation. One popular way to do this is to put your personal files and data on a separate partition, so if your OS gets corrupted or infected with certain types of malware, you can just wipe it and do a clean reinstall without also nuking your important stuff. Though it should be noted, this does nothing to protect that data from a physical drive failure. Partitions can also help, though, with a slow mechanical drive through a technique called short stroking. You see, because of the way that hard drive platters spin, the read or write head in your hard drive actually accesses data near the outer portion of the disk more quickly. Short stroking involves creating a partition that only takes up the faster outer portion of the platter. Not a bad place to install programs that you need to access quickly if you don't have room or you can't afford an SSD upgrade. So how do you create a partition then? Well, there's a wide variety of ways. You can actually specify multiple partition sizes when you're installing operating systems such as Windows. From within Windows, you can use disk management to actually shrink and expand volumes, which allows you to partition the space that is no longer being taken up by a volume. You can buy dedicated tools such as Paragon Hard Disk Manager. That's the one that we use around here at the office whenever we have to work with partitions. Or I'm sure that the comments are going to be full of everyone's favorite open source partition management software, and you can check out the most upvoted ones there as well. But there are downsides to partitioning. For one, because of file system overhead, splitting your disk into multiple partitions results in lower overall capacity than if you just had one big partition. You also have to configure Windows to store your data intelligently on a secondary partition, unless you want to just be manually moving things around. And the same goes for programs, because installing programs in one volume and then trying to move them over to another one is pretty much not a thing. Meaning that even if the idea was to save yourself from OS corruption, if you're installing a bunch of programs to that other drive, you're actually going to have to go clean them out manually and reinstall them anyway. But if you're the type of person that appreciates fine-tuning and tinkering, and you want your data backups there, and you want to put your managed files there, then don't be afraid of partitions. I mean, after all, where would we be without partitions in public bathrooms? I don't even want to imagine that kind of world. You know what other kind of world I don't want to imagine? One without Squarespace. Squarespace lets normal people like you build a simple, powerful, beautiful website the way you should. A live chat and email. It's only $8 a month to start, and you get a free domain if you buy Squarespace for the year.
All right, I'm gonna cut the video there to save us 3 more minutes. But I do apologize. You can go watch the real video to be able to see the video on Linus Tech Tips for a quickie for partitioning the drive. So again, you divide it for different operating systems, for different applications, putting your data in different places, and it allows you to use your hard drive to the fullest capacity. To partition, it can be done in 2 ways: through the Windows installation process when you're first installing operating system on your computer, or through the Windows Disk Management tool. You literally can add and remove partitions using these features. Something I learned when I went through A+, before I took the A+ class myself, many years ago, I thought once you made a partition, you were stuck with that size partition, but that's not true. You can expand partitions and you can shrink partitions as needed to make additional partitions, or you can combine partitions. Of course, you've got to move your data before you can release the one. Let's say you have partition C, and let's say you have C, D, and E, and you want to make D and E one partition. You would move everything from E to D, delete E, and then expand D. And you do that all through computer management. individual videos should show you how to do that. High-level formatting. Once you have your partitions, the second step is to use a high-level formatting. Now, a high-level format must be performed on all primary partitions, logical drives located within the extended partitions, and GPT partitions before data can actually be written to the hard drive. You also have to select the file system during this step. And there's many filing systems, FAT32, which is common with flash drives, exFAT made for removable drives. You'll see NTFS with Windows operating system, HFS for Apple, APFS, which is an upgraded HFS for Macs, and then EXT3 and EXT4 for Linux. Now, those are not all of the filing system. Well, I'll get to the newest one, which is the resilient filing system, REFS. But I did want to leave this on the screen, give you an opportunity to read through it. There are absolute limit reasons for partitioning in FAT32, exFAT, and NTFS. FAT32 came before exFAT, and exFAT came before NTFS. NTFS, down here it says it's the most modern, but that's not exactly true. If you go online and you do a search, you'll find that the most modern operating system is REFS, which is the newest filing system designed to maximize data availability, scale efficiently to large data sets across diverse workloads, and to provide data integrity with resiliency to corruption. So this is the newest operating system. Now, this operating system actually is not in the certification, A+ certification test you're studying for, but I didn't want to leave you with believing, as I did for the longest time, that NTFS was the newest operating system. It's not. It's just the newest one for the exam that you're studying for. I'm sure for the updated exam, you'll learn. They'll say that REFS is the newest model. Now, disk management, basic disk. You can have the primary partition. That's your C drive. That's what's bootable, and then you can have extended partitions for D and E, for example, for added division. So you can have maybe all your videos, all movies on D, and then all, I don't know, music on E if you wanted to do that. I think Linus did a pretty good job explaining it. You can also have multiple hard drive, and you can combine those onto a spanned or striped model. Now, I have a video for you for that about RAID. And RAID, I've mentioned it myself. I run RAID 5 in my home with 4 terabyte drives, giving me a redundant drive. Here is an explanation of RAID 0, 1, and 5.
Hey, Cheryl Schmidt here. I thought I'd take just a few seconds to explain real quick about RAID. I'm going to just do the RAID levels 0, 1, and 5. Those are the ones supported by Microsoft. But you can have hardware RAID, software RAID, and you might have other RAID options, 1001. But anyway, these are the basic ones. And once you get those, then you can catch the other ones. But anyway, RAID 0 provides no fault tolerance, but it does require 2 hard drives. So you have 2 hard drives installed. Say they're SATA. Say we've got 2 motherboard connectors that go to it. And say that you're writing a Dear Mom letter. RAID 0 is also known as striping. So part of the Dear Mom letter would be saved on disk 1, and part of the Dear Mom letter would be saved on disk 2. This actually is very, very fast. It speeds up your computer, but you got to think about before you put a RAID 0 in, one, that you have reliable drives and stuff. But what if you lost drive 2? You are up a creek and you just lost your Dear Mom letter, and there's no way to stop it to just put one file on one drive. So it is very, very fast, and so a lot of times the gamers will create a RAID and use that for saving their games and such. Now, RAID 1 actually does provide fault tolerance, true redundancy. I actually don't like RAID 1. I don't like what it does when you enable it. But you still got motherboard connections to 2 hard drives. You got hard drive 1, hard drive 2. So if I was writing Dear Mom letter, the entire Dear Mom goes on hard drive 1 and it goes on hard drive 2. Sorry, this is dinky, but I couldn't find any other better program to be able to capture. So anyway, Dear Mom goes on 1, goes on 2. If hard drive 1 goes down, you're still running. You can replace it and then it'll copy all your files back over. It does take time to rebuild a RAID. But anyway, RAID 1 is called disk mirroring. And it's truly fault tolerant. Now, RAID 5 is actually, back when I was over the servers and stuff, this was truly one of my favorite RAIDs. So it takes 3 hard drives as a minimum. So what happens is it gives you fault tolerance, but it does give you the speed of striping. So you got 3 motherboard connections, so you got 3 SATA drives and stuff, and you have a Dear Mom letter. So on one drive, you would stripe part of the letter, Dear. Another drive, you'd stripe the rest of it, and you save the file. On this third drive would contain parity information. So that if this drive here in the middle went down, you could take the parity information and the information that's stored on the first drive, and you could rebuild that middle drive once you replaced it. Now, one of the common misconceptions about RAID 5 is that the parity drive is always the same drive. That's not true. So if you had a Dear Dad letter, so the Dear could be striped on the middle drive, Dad, you saved it. That part of the letter gets saved on the third drive, and then the parity information would be stored on the first drive. And so the parity drive is not always the same drive, and so data is actually striped across all your drives. So if you actually lost, say, drive 1, you could use information from this drive to help you rebuild the Dear Mom letter. The Dear Dad letter is intact. You would just have to rebuild the parity information. And so, but I will tell you, rebuilding a RAID takes time if you do this. But a lot of people, it's actually come and supported on Windows 7, 8. They all come with RAID support, whereas used to, you'd have to get software that you would buy in order to support it. But it came to the desktop. So anyway, thought you'd enjoy.
All right. So that is, oh, I didn't need to close out of that. So that is RAID. Now, I do want to add to her explanation for RAID that the building can take a long time. And when she said about take a while, I've lost a hard drive before, and I started the rebuild process, and I went to bed because it took the 4 terabyte hard drive took hours to rebuild. Also, I want to point out that you can't lose 2 hard drives. So my RAID cabinet has every now and then I look up at my RAID cabinet to see if there's any errors lights on it, because if an error occurs in my RAID cabinet indicating a hard drive has gone down, which happens, I need to replace that hard drive as soon as possible, because if a second RAID drive goes down, then I lose everything. If I notice one hard drive has gone down, I turn off I figure out which one it is. On my RAID cabinet, it indicates drive 1, 2, 3, or 4. I remove the drive. I turn off the computer. I order an exact replica. One of the things about RAID is the drive should be as close as possible to each other. It's best to order 4 at a time to build your RAID. And then if you need to replace one of those drives, it should be as close as possible. I'm talking the same manufacturer, absolutely the same size. If I took 4 4-terabyte drives and I added, and one went bad, I added an 8-terabyte drive, that 8-terabyte drive would work, but it would format as a 4 terabyte drive. So I would be wasting my money. I would not have 3 4s and an 8. I would have 4 4s and I'd be wasting half of that drive. So a couple things to be thoughtful of. Also, there are other RAIDs. So RAID 10, for example, is 2, 4, I believe, 2, 5 RAID 5s that are striped together. I'm not positive, but 2 5s. The one, it's like having a mirrored 0. 10 is having both 1 and 0, but you have 2 RAIDs that are 1, and then it's sped up by 0. Anyways, but 1, 2, if you have 0, 1, and 5, you're ready for the exam and understanding the concepts of RAID. She also mentioned hardware RAID, and software RAID. So I have a external hardware RAID cabinet. The RAID controller is in the cabinet. It connects through one either USB 3 drive cable or eSATA cable. That's like a SATA cable that's on the motherboard exterior connector devices, and I can connect a external eSATA to my drive, and it acts like it's connected internally to a SATA connection. Or you can have on the newer hard drives, you can set up software RAIDs using that same computer management console to take 2 drives and create a RAID out of the 2 drives. We were able to do that in my when I went through the A+ course. We actually set it up, and this is the first time I set up a software RAID, and I was very surprised it was as easy as it was. Now, the one thing I remember from that process is you have to do it from scratch. You need to put 2 hard drives into the computer and then configure them as a RAID. You can't take an existing, you definitely can't do RAID 1 that way, because and then take one hard drive out a second and then make it a RAID cabinet. It doesn't work that way. 2 blank drives, set it up for RAID 0, 1, or 5 if you have 3, and then you're off and running with your software RAID. That way you can have both hard drives in your computer, and then it makes sense to have a RAID 1 because you have a backup of all your data with just 2 drives. One goes bad, you got to replace it quick because you obviously can't lose both. All right.
Cheryl Schmidt here.
Let's go on with the presentation. Changing drive partitions. We talked about extending, splitting, shrinking a few minutes ago, and you use the tools that are within computer management. This is the window, and this is what it looks like when you're trying to shrink, and then if you were expanding, it would tell you how much is available space, and then you just click on the button. Slow performance. Keep the computer system in a clean, cool environment to extend the life of the hard drive. Perform preventative maintenance on the entire computer is a good idea for all components, including vacuuming it out on a regular basis or blowing it out to get all the dust out of there and keeping it cool. Windows has 3 great tools in the hard drive preventative maintenance area: error checking, disk cleanup, and disk defragmenter. Now remember, well, let's go through the slides, but disk defragmenter should only be done on mechanical drives, never defrag an SSD or an M2 drive, which is an SSD drive. Here's to get to disk cleanup, access the Windows Explorer, right-click on the drive, go to Windows Explorer, not Internet Explorer, go to Windows Explorer, that's the yellow folder, right-click on the drive letter and select Properties. On the General tab, select Disk Cleanup, and in the Disk Cleanup window, click on the check boxes for the options desired and click OK. Now, it's going to offer you the opportunity to delete temporary files, installation files. Be aware of what you're deleting, because once you delete it, then it's gone. But it will free up some space. And if you have a hard drive running the disk defrag, if you find that you have a problem, run your error checking. It's called check disk. And check this, and it'll find bad partitions. I'm not sectors, bad spots on the drive. Now, if that happens, if you start finding errors on your hard drive, it's time to replace your hard drive. Yes, it will move data around and avoid that spot. Think about it as a pothole in a street. You learn how to drive around the pothole, but that pothole is hiding. Here in Florida, we have sinkholes. So that pothole might be hiding a sinkhole underneath that at some point your car is going to drive into the sinkhole. So you want to avoid the pothole, but you need to fix the street and check what caused the pothole in the first place, at least in Florida. Up north, we know what does it. Snow and plowing the snow, that's what kills the roads primarily. There's other things too. But anyways, a hard drive, if you're getting errors, you need to replace that hard drive as soon as possible, and you'll be in good shape. I actually run a program that I highly recommend. It's a free program. Let me pull it up. Okay, so instead of me putting my hard drive information out there on the internet, I think a better idea would be to share the actual program I use. There's a free version and a pro version, and this is what it looks like. It shows you all of your hard drives that you have on your computer, and it tells you if there's any problems. Now, Smart tells you when your drive is failing. If your drive is 100% working great, then great, leave it the way it is and know you have some time. It tells you how long your computer's been on, how much time is remaining for an estimated lifetime of more than 1,000, more than 3 years, and total stop and start count, how many times that drive's been stopped and started. Now, if it finds a problem, you can run a test on it and it will test that drive. They don't have a picture of problems, but here we have a temperature issue. You might consider adding some cooling to cool that drive, relocating the drive. But it will start telling you that your health is less than 100%. And you can see logs of error messages that you get. You can clear the logs, and then if the error comes back, you know that it's a real log. Ultimately, you can run some specific tests on that drive. So anyways, I like it. It's called Hard Disk Sentinel, and there is a free version and a paid version, like just about everything else out on the internet. The free version, the paid version has some additional components. All right, so that is, oops, we already covered that. So that is this presentation. Again, it comes from the complete A+ guide to IT hardware and software for the CompTIA A+ 220, 1001, and 1002 exams from Cheryl Smith. That's where the PowerPoint comes from. You heard her talking during the presentation. Hopefully that information was helpful. Hopefully the entire presentation was helpful. My name, again, is Don LaFond, and I am, thank you for staying through the presentation. If you have any questions and you're here with me live, you have a moment to ask those questions. If you are watching this presentation in the classroom, please ask the questions in the help discussion forum, in our Canvas help discussion forums. I'll try to answer those questions as soon as possible. Help each other out too, as I ask you to do out on the internet. If you're watching this out on YouTube's, thank you so much for finding my channel, watching my video. Please give it a thumbs up and make comments down below. Hopefully it's been helpful for you. And follow and also hit that notification that I'm making these videos in the summer of 2022. And you will be notified when the next video comes out. So that is helpful for you as well. Again, thank you so much for coming to class. Enjoy studying and enjoy learning about setting up your hard drives. And I will see you again in a week.